So, hello everyone, I Raghavendra Singh welcomes you all. Welcomes you all in the part 2 video of Laplace transformation. Laplace transformation. So in the part 1 video I have discussed about basics of Laplace transform. So let's discuss the topic, that is first shifting theorem. First shifting theorem. Okay, first shifting theorem. So what is first shifting theorem? So we have to remember this concept, that is Laplace of ft is equal to phi of s. Then Laplace of a to the power minus at f of t is equal to phi of s plus of a. Okay, so this is first shifting theorem. This is if e to the power this, if l e to the power only at and f of t, then this will be phi of s minus a. Okay, then this is so simply just there is only one thing which we need to remember. If here this is, then we will put this. If this, then we will put this. Okay, yes, so simply just we have to remember, if e to the power minus 80, then we will put s plus a. If e to the power only 80, then we will put s minus a. Just simple. Now let's take example. It will be much clear through the example. So find the Laplace transform. Find the Laplace transform. Find the Laplace transform e to the power 4t sine cube t. Okay, this is Laplace transform which we have to find. I can also write 4t into sine cube t. Okay, so here Laplace of f of t, Laplace of f of t, Laplace of sine cube t. So firstly we know the how can we find the sine cube t. So here we will use formula. What is formula? 1 upon 4 Laplace 1 upon 4, it was all just Laplace 1 upon 4 into 3 sine t into 3 sine t, 1 upon 4 into 3 sine t minus sine 3t, right? Sine 3t. So this is the formula which we have used. Now I can easily find the Laplace of sine t, right? No, 1 upon 4 I can take common. So now I can simply find Laplace of 3 sine t minus Laplace of sine 3t, right? So what is Laplace of sine 80? That is a upon s square plus a square. So 1 upon 4 s 1 upon 4, 3 I can take common, like 3 is a constant, so bahar hi rahega. 3 into a upon a is 1, so 1 upon s square plus 1 square. Okay, minus a upon a is 3, so a is 3 upon s square plus a square. A square is 1, so a square is 3, so 9. A is 3, so 3 square 9. Okay, and now Here 3, here 3, I can take common 3 upon 4. I hope this all visible. Yeah, 3 upon 4, 1 upon s square plus 1 minus 1 upon s square plus 9. Okay, so from here onwards we can solve. If we are solving till there, then also we will get the marks. But now the main part starts. So what is main part? Now we will use first shifting theorem. Now we will use first shifting theorem. Okay, so first shifting theorem. So Laplace of e to the power at f of t is equal to phi of s minus a. Okay, phi of s minus a. So here what is given, that is Laplace of e to the power 4t sine cube t so here what is s minus a. So here a is 4, right? So means s will be replaced by s minus 4. Okay, so this is first shifting theorem. So s will be replaced by s minus 4. So I will simply put here s minus 4. So 3 by 4 upon 1 upon s minus 4 का square plus 1 minus 1 upon s minus 4 square plus 9. Okay, now I can also open it by using a square plus b square formula. So 3 upon 4 1 upon s square plus 16 plus minus 4 to the 8s plus 1 minus 1 upon 9 plus s square plus 16 plus 8s, sorry, minus 8s. So as you can see that 16 and 9 we can add. So 16 plus 9, 25, and this 16 plus 1 is 17. So I can write 3 upon 4 1 upon s square minus 8s plus 17 minus 1 upon 9 1 upon s square minus 8s plus 25. Okay, so this is the final answer. So let me repeat it what I did. That is simply what is first shifting theorem. We have to follow the same process as we were following in the previous questions in the part 1 video. That firstly we have to find the value of sine cube t. So I cannot find the right value of sine cube t. So what I did is I used the formula. Then after using formula I can simply find out the value of sine cube t. Then the main concept is we have to replace s by s minus 4. So here is a, basically formula is phi s minus a. So here is a is 4, so s minus 4. Okay, so I have replaced s by s minus 4 and nothing else. Now let's take the another example. So question number 2 is Laplace of cos ht cos h2t into cos 2t. Okay, so we know the formulas. That is, what is formula of cos hyperbolic x? Cos hyperbolic x formula is e to the power x plus e to the power minus x upon 2. Okay, so this is the formula of cos hyperbolic x. So here is t in the form of t and 2 also. So e to the power 2t plus e to the power minus 2t upon 2. Okay, now here is cos 2t. So I will simply multiply it from this. So I can write Laplace of e to the power 2t plus e to the power minus 2t upon 2 into cos 2t. Okay, so I can take 2 as common. So I will multiply e to the power 2t into cos 2t. 1 by 2 I have taken common. E to the power 2t into cos 2t plus e to the power minus 2t into cos 2t. Cos 2t. Okay. So now I can simply find the Laplace of cos 2t, that is s upon s square plus a square. So e to the power 2t as it is s square s upon s square plus a square. A is 2, so 4, plus e to the power minus 2t e to the power minus 2t, so cos 2t, so s upon s square plus 4 again. Okay, e to the power minus 2t. And 1 upon 2 is outside. So now use the first shifting theorem. Now we can use first shifting theorem. So first shifting theorem, as we know that here a is equal to 2, so formula is s minus a, so s will be replaced by s minus 2 in the first one. Okay, and this will be replaced by s plus 2, right? So 1 upon 2 outside. So here as you can see s, so s minus 2 upon s minus 2 square plus 4 plus s plus 2 upon s plus 2 square plus 4. Okay, so I can write 1 upon 2 s minus 2 upon s square minus 4s plus 4 plus 4 plus s plus 2 upon s square plus 4s plus 4 plus 4. Okay, I can also write after solving it 1 upon 2 s minus 2 upon s square minus 4s plus 8 plus s plus 2 upon s square plus 4s plus 8. Although we do not need to solve as much, I can also write till here, then examiner will give me a full mark. So yeah, that's it. This is the final answer. So what I did here is, now simply as you can see we have hyperbola function. So I know the formula of hyperbola function, that is e to the power x plus e to the power minus x upon 2. So I have just used simple this formula. Then after this is this, and I know the Laplace of cos 2t means cos 80 s upon s square plus a square. So I have used the formula. Then simply I have using first shifting theorem, I have replaced s by s minus 2. Okay, now let's take the new example, question number 3. So question number 3, we have to find Laplace transformation of sine hyperbolic function of 80 into sine 80. Okay, So now simply I will use here formula. So sine hyperbolic of 80 formula is e to the power, I can simply write 80 e to the power x e to the power x minus e to the power minus x, right? E to the power minus 80 upon 2. Okay, so I am replacing it here, and we know the formula of sine 80, that is sine 80, that is simply a upon s square plus a square. So Laplace of e to the power 80 minus e to the power minus 80 upon 2 into a upon s square plus a square, a upon s square plus a square, a upon s square plus a square. Okay, so from here I can take 1 by 2 common. Yes, so what I can do here is that I'll put sine 80 after, so I'm not writing it 1 upon s square plus a square right now. Sine 80 as this I'm writing. So what I can do is I will multiply, simply I'll multiply it. So 1 upon 2 I can take common, 1 upon 2 Laplace of e to the power 80 into sine 80 minus e to the power minus 80 into sine 80. Okay, so now I can write a upon s square plus a square minus e to the power minus 80 e to the power minus 80 1 upon 2 s square plus a square. Okay, now here as I can see, s can be replaced in this, s can be replaced as s plus a, and in this s will be replaced as, no, in this it will be s minus a, and this s will be replaced by s plus a. Okay, so 1 upon 2 a upon s minus a square plus a square minus e to the power minus 80 s square s plus a square plus a square. Okay, so this is final answer. I hope it's all visible. Now let's move on to the next question. That is question number, it was question number 3. Move on to the question number 4. Question number 4 is Laplace of cos 2t into sin t upon e to the power t. Okay, so this is the question. So let's discuss, or I can write this as Laplace of e to the power minus t into cos 2t into sin t. Okay, you know that 1 upon x can be written as x inverse, right? So I did here that only, nothing else. So as you can see, division multiplication, so you all know that what we have to do is we have to simply convert it in the plus or minus sign. So this is a and this is b. I can simply use cos a into cos b formula, cos into cos b formula. So what is cos into cos b? So here cos into cos b is 1 upon 2 sin a plus b, 1 upon 2 sin a plus b, 1 upon 2 sin a plus b minus sin a minus b. Okay, so Laplace of e to the power minus t into cos of a plus b. cos of a plus b means 3t minus, sorry, sine of a plus b, sine of a plus b, sine of a plus b, sine 3t minus sine of a minus b. 2t minus t is t only. Okay, so 1 upon 2 also, 1 upon 2. So we have done this till here. Now 1 by 2 taken as common. So 1 by 2 Laplace of e to the power minus t sine 3t minus e to the power minus t. I have multiplied by e to the power minus t into sine t, okay. Now I can simply find the Laplace of sine 3t. What is Laplace of sine 3t? A upon s square plus a square, that is 9. And what about Laplace of sine t? Laplace of sine t is equal to 1 upon s square plus 1. Okay. Yes. Now by first shifting theorem. I hope this whole recording. By first shifting theorem. So as you can see that here a is equal to minus, so here a is equal to minus 1, a is equal to minus 1, here a is equal to minus 1. So formula phi s minus a. Okay, so s will be replaced by s minus minus plus a. Okay, so s will be replaced by s plus a. So 1 upon 2, 1 upon 2, 1 upon 2 in this, so 3 upon s plus a square plus 9 plus 1 upon s square is s plus a square plus 1. Okay. Sorry, so this is x plus 1, s plus 1, okay, s plus 1. So here will be s plus 1, this also s plus 1. Okay, now we can solve it further, or I can write it as an answer. Okay, now let's move on to the next. And next question is, now simply let me recall that what I did. Simply we have this question which is given, so I cannot solve it while it is in multiply, so I have to use formula which I have used, cos into cos b. Formula is 1 upon 2 sin a plus b minus sin a minus b. So I have used this formula, then simply I have put the value that it is a is equal to minus 1, then s minus a means s minus minus 1, so s plus 1. Okay, so then I have put the value s of s plus 1. Now let's take another question, that is Laplace of e to the power minus 3t cos of hyperbolic 5t into sine 4t. Okay, so now let's find separate Laplace of cos h 5t means it is again hyperbolic, then e to the power minus e to the power 5t plus e to the power minus 5t upon 2. Okay, now Laplace of sine 4t is equal to sine 4t. What is sine 4t means? E square. Sine 4t means for a upon s square plus a upon s square plus a, right? A upon s square plus a square means 16. Okay, this is sine 4t. Now I can simply put here, so again remember that Laplace of e to the minus 3t, e to the minus 3t and e to the power 5t plus e to the power minus 5t upon 2 into sine 4t. Okay, into sine 4t. So I can take 1 by 2 common. 1 by 2 Laplace of here as I can see sine 4t e to the power minus 3t sine 4t into e to the power 5t plus e to the power minus 5t into sine 4t. Okay, yes. So now e to the power minus 3t. So if I am multiplying it from this, then as you can see e to the power minus 3t, here is e to the power 5t. So e to the power minus 3t into e to the power minus 5t. This will be e to the power 2t only. So I can write 1 upon 2 e to the power 2t only into sine 4t plus e to the power minus 8t e to the power minus 8t into sine 4t into sine 4t. Okay, yes. I'm sorry. So let's begin. Yes. So what I can do is so I have already funded the sine 40. So now I will simply put the value. So 1 upon 2 Laplace 1 upon 2 e to the power 2t into s, that is 4 upon s square plus 16 plus e to the power minus 8t into 4 upon s square plus 16. Okay, yes. So now here as you can see here s is replaced by, I'm not writing complete, s will be replaced by s minus 2. Okay, here s will be replaced by s minus s plus 8. Okay, so 1 upon 2 s minus 2, s will be replaced by s minus 2 e to the power 2t s minus 2t. So 4 upon s minus 2 square plus 16 plus 4 upon s plus 8 square plus 16. Okay, yeah. So this is the answer, or I can also write it after opening s minus 2 after using formula simple a plus b ka whole square. Okay, so what I did here is simply, first of all, we have to do is that we have to do what we know, that we know the hyperbolic function of cos A. So I have simply used this formula, then simply I have put it. Now I have to make it as simple as possible. So I have make it as simple as possible. Now simply I have put it the value and I find the answer. Now for homework you can do this was question number 5, right? This is question number 5. So it is Laplace of sine 2t into cos t into cos hyperbolic 2t. Okay, yes. So as you can see that here we cannot solve it directly. So what we will do is we will firstly use this formula. It is e to the power x, here we will 2t, then e to the power 2t plus e to the power minus 2t upon 2, and here simple cos 80 formula we can use, and here sine 80 formula. Okay, it is very simple. I hope you all can solve. Now let's move on to the effect of multiplication. The next topic is effect of multiplication. So effect of multiplication. Okay, effect of multiplication. So what is concept? Simple multiplication will be, suppose u into du or t into dt as a something multiplication. Let's take the example. For example, we have to find the Laplace of t into sine cube t. Okay, so as you can see here, t is in multiplication. So how can you solve it? Now I cannot use the formula, I will use the formula of sine cube t, but after using the formula, then what I will get? 1/4 and this out. So is that possible to solve this question from this formula only? No, here's t, so we have to think it differently. So basically what I will do is, so although concept is just nothing, concept is by multiplication is that anything to the power -1 and into d upon ds or f of t, function of t, which is given. So this is the concept. Let me discuss. So basically first of all, we know the formula of sine cube t. What is formula of sine cube t? It is 1/4. It is 1/4 3 sine t minus sine 3t minus sine 3t minus sine 3t. Okay, so this is the formula. So I can put it here. Laplace of 1/4 I can take common, t into 3 sine t minus sine 3t. Yes, sine 3t. Okay, yes. So now sine 3t, 3 sine t. So 3 as it is, a is 1, so into 1 upon s square plus 1 minus 3 as it is means a upon s square plus 9, right? So here this into t as it is. Now 3 I can take common, so 3/4 t into 3/4 t into 1 upon s square plus 1 minus 3 upon s square plus 9. So now we will use simple formula. As you can see that here is nothing, here is not anything to the power, so I will write simple -1 only. So -1 into d by ds also 3. Now simple f of t. What is f of t? This is f of t. So I will write also 3/4. So 3/4 I am writing here into, we have to differentiate 1 upon s square plus 1 minus 3 upon s square plus 9. Okay, yes, this. So simply now we have to solve this only. -3/4 d upon ds 1 upon s square plus 1 minus d upon ds 3 upon s square plus 9. Okay, we have to solve this one only. So differentiation we have to solve. So what is differentiation of this? It is 1 upon s square plus 1 So I think here we can use the formula that is a upon x square plus a square, right? A upon x square plus a square, it is 1 upon a tan inverse x upon a, right? Tan inverse x upon a. Yeah, I'm not sure. Let's solve from this formula. I'm just trying it what I can do. So basically here x is s and a is 1, right? And here x is s and a is 3, right? So I am simply putting the formula. So minus 3 by 4. So 1 upon a is 1 only, so 1, right? But tan inverse x by a, so x only, right? Minus 3 1 upon a 1 upon 3 into tan inverse x upon a 3 upon a no, x upon 3 yes, I hope we are achieving. So minus 3 by 4 tan inverse x minus 1 by 3 tan inverse x by 3. Okay, so this is answer of the question. I can solve it till here only. So what I did is simply I did this. I have used this formula, then this and this and then this. Now let's take the another question, that is question number 2. Laplace of t into e to the power 3t sine 4t. Okay, yeah. Sine 40. So basically, as you can see here, this and this. So first of all, we will find the Laplace of sine 40, which is a upon s square plus a square, that is 16. Okay, s square plus a square by first shifting, I think. What can I do is now simply, as you can see here, it will have 3t. So now here by first shifting theorem. So yeah, one thing that how will you remember that it is here I will use first shifting, here I will use multiplication, here I will use division formula. It is very simple that as you can see here e to the power anything, it means we will use first shifting only, and t multiplication we can see, then we will use multiplication. What we do in multiplication, that is we do differentiation. So but we need to remember this only, nothing else. So first shifting theorem means here s will be replaced by s minus a, that is s minus 3, right? Yeah. So 4 upon s minus 3 square plus 16, right? So if I am opening it, then s square minus 3 2 just 6s, 3 3 just 9 plus 16, 9 plus 16 25. Okay, I'm writing it complete. So 25. Now simply use multiplication theorem. So what is multiplication theorem? Yeah, so multiplication theorem is simply like I'm writing it completely. Laplace of t into e to the power 3t sine 40, right? So what is multiplication theorem? That is so in multiplication theorem, yes, so what can I do? Here simply minus 1 to the power just 1 only, because there is nothing in the power, and differentiation of this, right? So 4 upon s square minus 6x plus 25. Okay, now simply I have to differentiate it, nothing else. So I'll use here u by v rule, u into v rule. So we know that if this will be differentiated, then this will be as it is now, and v square, so minus 1 into this is considered as u, this will be considered as v. Okay, so first u differentiation, this will be 0, this will be 0, anything to the power this doesn't matter, into minus 1, s square will be, differentiation will be 2s minus 6s, integration will be 6, right? 25 will be 0 upon s square minus 6s plus 25 the square. Okay, yeah, so 2s minus 3, or I can write 4 2 ja 8 s minus 3 upon s square minus 6s plus 25. Okay, so this is final answer. Now let's do question number 4 on multiplication theorem. So question number 4 is Laplace e to the power minus 3t cos of hyperbolic 5t into sine of 4t. Yes, so again what I will do here is I'll use simple cos hyperbolic of 5t, that is equal to e to the power 5t plus e to the power minus 5t upon 2. Okay, so I can take 1 by 2 as common. Laplace of e to the power minus 3t into e to the power 5t plus e to the power minus 5t into sine 4t. Okay, so e to the power minus 3t, I'm just multiplying this from e to the power minus 3t to L upon e to the power minus 3t into e to the power minus 5t, e to the power minus 3t into e to the power minus 5t, so e to the power minus 8, e to the power minus e to the power 2 only, e to the power 2 only, e to the power 2, right, plus e to the power 8 minus 8t, okay, into sine 4t. Okay, and now into sine 4t. Now simply I multiply it from sine 4t, 1 upon 2 Laplace of e to the power 2t into sine 4t plus e to the power minus 8t into sine 4t. Okay, so yeah, now simply I can find what is sine 4t Laplace. Sine 4t Laplace is 4 upon s square plus a square, s square plus 16, and yeah, so 1 upon 2 e to the power 2t 4 upon s square plus 16 plus e to the power minus 8t 4 upon s square plus 16. So here as you can see, s can be replaced as s minus 2, here s can be replaced as s plus 8, right? So 1 upon 2 4 upon s minus 2 square plus 16 plus 4 upon s plus 8 square plus 16. Okay, so I can leave it here only and I'll get the marks. Okay, so now next question I will just help you orally that how can we solve. So question number 5, that is Laplace of sine 2t into cos t into cos of hyperbolic 2t. Okay, yes. So what can we do here? Simply here we will use the formula of cos hyperbolic t, and now whatever will be, and here we will use simple sine of at, and this is cos of hyperbolic at. And now simply then after whatever will be answer, then we will multiply each one and I'll get the answer. It's very simple. Okay, so I'm not solving this, so do it by yourself. Okay, now the next type of question, that is question number 6 on multiplication theorem. It is Laplace of t into 1 plus sine t. Okay, what will be Laplace of this? So see it very carefully, that is we will use here formula, that is 1 plus sine t is equal to cos t by 2 plus sine t by 2. Okay, cos t by 2 plus sine t by 2. So Laplace of cos t by 2 plus sine t by 2, you can write, right? So Laplace of cos t by 2 upon sine t by 2 plus sine t by 2 plus sine t by 2. So now simply I will write t after, but firstly we have to write cos of at, hyperbolic Laplace of cos of at. Here a is 1 by 2, right? So I can write that is s upon s square plus 1 by 2 square, and sine of t by 2 1 upon 2 upon s square plus 1 by 4. Okay, 1 by 2 s square plus 1 by 4. Yes, so I'll put it here. Laplace of, I'm solving, after solving I can write 4s square plus 1 plus 2 upon 4s square plus 1. Okay, after solving this all I can write this. And now I'll use multiplication theorem. Multiplication theorem. So what is multiplication theorem? Simply just whatever we have, d upon ds 4 of s upon 4s square plus 1 plus 2 upon 4s square plus 1. Now here we will use u into v rule. Okay, So what we had, that is minus 1 d by ds 2s plus 1 upon 4s square plus 1. So here u into v rule. So this is v and this is u. Okay. So let's keep a minus 2 common, and 2s will be, and this will be as this. Let's v take it as this. So 4s square plus 1 as this into differentiation of this one. So 2 plus, sorry, minus 2s plus 1 as this, 2s plus 1 as this into differentiation of 4s square means 8s. Okay. Yeah, and upon this square. So 4s square plus 1 whole square. Okay. Yes, so I can solve it further, like after multiplying it through, and I can write. Also, I can write this only, so this will be considered as my answer. So now let's discuss about division property. Let's discuss about division property. Effect of division by t. Okay, effect of division by t. So basically main concept is, if we have function of t is equal to phi of s, then 1 upon t function of t is equal to s to infinity, remember limit integration s to infinity phi of s into ds. So this is the concept which we have to remember. We will be given like this. So after solving, we have to write on this whatever will be here. So I will write it here. So basic properties of log, what we have to remember is some basic properties of log which you have learned in 12th class. Basic properties like what will be log a plus log b, log a minus log b, and all. Okay. Yeah, so let's take example. So question number 1 on division property. It is, find the Laplace of 1 upon t 1 minus cos t. 1 upon t 1 minus cos t. Okay. Yes, 1 upon t 1 minus cos t. So here simply we will use this. So I am just writing it separate. So firstly we will solve Laplace of 1 minus cos t. So what can I write? Laplace of 1 is 1 upon s, right? We know. And Laplace of cos at is minus s upon s square plus a, right? S square plus a. Now simple using the formula, but like if we have 1 upon t into f of t, then I'll write s to infinity phi of s into ds. Okay, so s to infinity this 1 upon s minus s upon s square plus a into ds 1 upon s square upon s upon s square plus a. So now what can I do is, now simply we have to just integrate it, nothing else. So here I will balance it. Here I will multiply it by I multiply it by 2 upon 2. Okay, here also 2 upon 2. So this 2 can be taken as common. 1 by 2 I will take common, and this 2 upon s will be 2 log x. What is integration of x? I know integration of x into dx is log x, right? So integration of this will be 2 of log s, right? So 2 can be taken as power of s, so log of s square, right? And this here, this can be written as log of s square plus 1, right? So I will take 1 by 2 common and 1 by 2 common and log of s square, right? Log of s square minus log of s square plus 1, right? Yeah, so now we know the property that if we have log a minus log b, then it will goes in divide. So log a upon log b, so log b upon a, right? Log b upon a, so 1 upon 2 log of b upon a, so s square plus 1 upon s square, right? Yeah, so s square plus 1. So now I will simply put the limit r as to infinity. So see here, so infinity, like I am not writing, I am just writing. So log infinity, I will put infinity square plus 1 upon infinity. So infinity will be cancelled. So here will be what? Infinity upon infinity. So here will be 1. So log 1 is always 0. We know this. Log 1 is always 0. So if 0 we are writing or not writing, then it doesn't make any effect. So I'll put s. So what I will get is 1 upon 2 log of s square upon s square plus 1, s square log of s square plus 1 upon s square. Okay, so this will be as it is. This is answer. Okay, now let's take the another example. Question number 2. Laplace of sine square 2t upon t. So I know that sine square theta formula and sine square t here, sine square 2t. Okay, so it is 1 minus cos 2t, right? 1 minus cos 2t means cos 4t upon 2, right? So I'll put here, so 1 minus cos 4t. So Laplace of 1 minus cos 4t, 1 by 2 I have taken common. So Laplace of 1 is 1 by s minus cos 4t, means s that is s upon s square plus a is 4, so 16. Okay, Yeah, so this is it. Now here, as we can see, division property. So I'll use division property. So 1 upon 2 taken as common, s to infinity, 1 upon s minus s upon s square plus 16. So 2 upon 2, again I have balanced it, just nothing else, and 2 upon 2 also here. So here this, now integration will be ds, also I have to write. So this and this integration will be log s square, right? So 1 upon 2, 1 upon 2 I have taken common, so 1 by 4 here will be, and 1 upon 4 here will be log of s square. I don't know what to do. Yeah, so I can simply write log of s square minus 1 upon 2. 1 upon 2 I have taken common, so log of s square plus 16, log of s square plus 16 only. Okay, and now log, simple log property. So 1 upon 4, here also limit, which we have to not forget, s to infinity log of a b upon a, b s square plus 16 upon s square. So s to infinity, right? So s to infinity. Now simply we will put the value. Again I am putting infinity, then this will be again 0, so I am not putting infinity. So 1 upon 4 log of in place of s I will again put s plus 16 upon s square, same. Okay, so this is our final answer. Now let's take the another question, that is question number 3. It is prove that 0 to infinity, prove that 0 to infinity e to the power minus t sin square t upon t dt is equal to 1 upon 4 log of 5. Okay, yes, so we have to after solving we have to show it like this. So what can we do is simply we have to find the Laplace of sin square t. So I know the formula of sin square t. Sin square t is equal to 1 minus cos 2t upon 2. So now like I can take 1 by 2 common, and Laplace of this one, Laplace of 1 will be 1 by s. I'm not solving it step by step, I'm just solving directly. I'm trying to skip as many steps as I can do, because I do not want to so much lengthy, although I can easily fill 2 pages with this question only. I do not want to do that. Okay, so cos 2t, Laplace of cos 2t means s upon s square plus a square, that is 4. Okay, now division property. Division property by t. So 1 upon 2 s to infinity 1 upon s minus 2s upon s square plus 4. s square plus 4. Sorry, this is not 2. I have balanced here 2 and upon 2. This is also 2 and 2. I will take 2 common, 1 by 2 common. So here will be 1 by 4. Again, as you can see that 1 upon s, so log s square. So this will be log s square minus minus 1 upon 2 log s square minus 1 upon 2. Yes, so minus 1 upon 2 here it will be log of s square plus 4, right, into ds. Yeah, so simply now that property only. So log of s square, so s square plus 4 upon s square. Okay, yeah, so now simply on s to infinity, that property s to infinity. So I'm not putting infinity because you know that it will be 0 only, so I'm putting s. So if I will put s, then this will be only, so 1 upon 4 1 upon 4 1 upon 4 log of s square upon s plus 4, or s plus 4 upon s square, doesn't matter. Just remember, I think I have did some mistake there also. Here minus, so here everywhere will be minus. If I want to remove minus, then I can write s square upon s square plus 4. I did this mistake everywhere, so please take care of that. Yeah, so now here we can see e to the power minus t, e to the power minus t. So what, this is also first shifting theorem we will use. First shifting theorem. So e to the power minus t. So first shifting theorem, okay. F is equal to minus 1. F is equal to minus 1. Okay, so I'll put f is equal to minus 1 here. So 1 upon 4 log of minus 1 means 1 upon 1 plus 4. So 1 upon 5 log of 1 upon 5. So 1 upon 4 log of 5, right? Although I think I was right. No, we do not need to do this. So 1 upon 5, this will be, here will be 1 only. So log of 5, as you can see we have proved, hence proved. So simply I did just nothing, I can say that simply I have balanced it, and simply I have used the basic property of log, and we have proved it very simply. Now I am just almost tired. Now another question is, in 0 to infinity e to the power minus 2t cos 2t into sin 3t dt. So simply sin 3t and 2t, we can see that if this will be a, this will be b, then simply cos sin a into cos b. I'll use that formula, then simply I can solve it. I'm not solving it complete, you can solve, do it by yourself. Let's move on to the Laplace transformation of derivative and integral. Laplace transformation of derivative. Laplace transformation of derivative we will do firstly. So what is Laplace transformation of derivative? Simply here we will be given that f dash of t so we will put it as s of phi of s minus f of 0, right? So we will put it. So main concept we have to remember this will be the form of question and we have to convert in this form. That will be considered as integral of Laplace transform. So let's take the example of question number 1. We can write question number 1. So if f of t is equal to sin t upon t, find f of f dash t. F of f dash t find f of f dash t. Yeah, so simply what I can do is I will simply find the Laplace of sin t first. So what is Laplace of sin t is 1 upon s plus a, 1 upon s square plus a, that is 1. Okay, yes, and now Laplace of sin t by t. Laplace of sin t by t. Laplace of sin t by t. So s to infinity so as you can see here is a division property, right? So s to infinity 1 upon s square plus 1 into ds. So as you can see here we will use 1 upon x square plus a square, right? So we will use 1 upon a tan inverse of x upon a, right? Yeah, so my energy is almost very down because I'm just doing this from the morning onwards. So I'm sorry if you think that I'm very tired. So yeah, it is correct. Tan inverse x by a. So I can simply put here. So s to infinity 1 upon, no, I'll solve it directly. So 1 upon a means 1 only into tan inverse x upon a, x upon 1 again, limit s to infinity. X is here s, right? X is s. Now I'll simply put the value, that is tan inverse infinity minus tan inverse s. So tan inverse infinity is pi by 2, right? Minus tan inverse s. So we know the formula that pi minus tan inverse s can be written as cot inverse x, cot inverse s, right? So now what is property? This is the property. So I will put f of s. I have found it that cot inverse x, cot inverse s. So what f of 0 will be? F of 0 will be 0, right? F of 0 will be sorry, this is cot inverse s. Okay, now we have given that f of t is equal to sine t, so f of 0 will be sine 0 0, right? But if f dash t is equal to minus cos t, so f dash 0 will be minus cos 0, so this will be 1 minus 1, right? Yeah, so sorry, and differentiation of sine is simply cos, not minus cos, so 1 only. Now simply I can put 1 here in this, so f dash t so the f of f dash t is equal to cot inverse of s minus 1. Okay, so I can write this is the answer. Now the other question is, we have to find the Laplace transform of d by dt 1 minus cos 2t upon t, 1 minus cos 2t upon t. So first of all, what we will do, we will find the simply Laplace of 1 minus cos 2t. So Laplace of 1 is 1 upon s minus s upon s square plus 4. Okay, yes, so an integration from s to infinity, because here it is division property. I'm not writing each step right now, I'm solving it directly. So now dot ds. So now what can I do is, again I'll just balance it. And I'll balance it, multiply by 2, divide by 2, multiply by 2, divide by 2. This whole and this. I can take 1 by 2 common. So 1 by 2 I have taken common. So 1 by 2 I have taken common. One by 2 I have taken common. So 1 upon s is log s square minus log of s square plus 4. Log of s square plus 4, right? Dot ds. No, we have integrated it already. So now simple, I can use the property of log. So again, log of b upon a square, s square plus 4. Yes. So s to infinity property. So again, if I am putting infinity, then again it will be 0. So I am putting s only. So 1 upon 2 log of this negative is here. So 1 upon 2 log of s square plus 4 upon s square. Yes, so not a big deal. Now what can we do is, As you can see here, this is log, right? So if this 2 will be in the upper side, then it will be 1 upon 2. So I can also say root, right? So I can also write log root of s square plus 4. I hope you have understood whatever I said, upon s. So and now for f of t is 1 minus cos 2t, 1 minus cos 2t upon t. If I am putting f of 0, then here will be 0, so not defined, right? So now differentiation f of t is 1 minus, so t means t differentiation, it will be 1, it will be t cos 2t as it is into cos 2t as it is minus cos 2t differentiation will be minus plus sin t, sin 2t into 2, right? Yes, so minus plus sin 2t into 2. So upon 1 we know. So here t is 0. Here t is 0. So I put here t 0. This was also 0. So 0 plus sin 2 to 0. So 0 plus 0. So f of t is 0, right? Now simply I have to put it. So s of phi of s minus f of 0. So s log of root of s square plus 4 upon s minus 0. Okay, so this is the final formula, final answer which I have discussed. Now let's discuss the last topic, that is Laplace integral. Laplace integral. So basically the concept is I hope you all can see this. So concept is Laplace of f of t is equal to phi, then Laplace of 0 to t f of u tu is equal to 1 upon s phi of s, right? Yeah. So this is the concept. Let's take the question number 1. Laplace of 0 to t u into cos square u du. Laplace of cos square u. Firstly we will find it, then cos square theta simply. So I can use 1 plus cos 2u upon 2. One upon 2, 1 upon s plus s upon s square plus 4, right? Laplace of 1 and Laplace of du, that is s upon s square plus 4. So now simply the use of property. So here we can see that is u into cos square u into du. This, so multiplication rule. Here I will use multiplication rule. So do not forget multiplication rule. What was multiplication rule? Minus 1 to the power 1, because there is nothing in the power, d upon ds, and 1 upon 2 of 1 upon s plus s upon s square plus 4. Okay, yes. So minus 1 upon 2 minus 1 upon s square plus s square plus 4 I have just differentiated it. What is differentiation of 1 upon s minus 1 upon s square plus 4 into 1 minus s into 2s, right? Here what I have done is u into v rule I have followed. Okay, yes. So the final it will be 1 upon 2s square, the finally s square minus 4 upon 2 s square plus 4 square. Okay, now simply use the property. Now integral property that is 1 upon s 1 upon 2s square plus s square minus 4 upon s square plus 4 whole square. Okay, yes. Let's take the another question. This is going to be last question, I think. Integration 0 to t e to the power minus 2u cos square u du. So Laplace of cos square u, I know this is going to be 1 plus cos 2u upon 2. So now by first shifting, here I can see I will use first shifting by first shifting theorem. So by first shifting theorem, so s can be replaced as s plus 2, right? So s can be replaced as s plus 2. S can be replaced as s plus 2. So now simply here the Laplace taken 1 by Laplace 1 upon s plus s upon s square plus 4, right? And here s can be replaced as s plus 2. So 1 upon 2 1 upon s plus 2 plus s plus 2 upon s plus 2 square plus 4. Okay, yes. And now simply we'll put the value 0 to t. I hope you can solve this. So thanks for watching. On this side, okay, so here we have finished unit number 3, that was Laplace transformation. Now we will start in unit number 4, that is going to be Fourier series. Okay, yeah.